Okay, let's start with adding and subtracting. This was the easiest thing from this unit, and generally you all got it right every time you did it, except for the small exception when you would make a silly like sign mistake. Remember, it's just with subtraction, you need to worry about distributing that negative into the parentheses. So I'll work through one example of subtraction, but the addition case is ridiculously easy. It's just combining like terms. So let's do a subtraction one. So 3x to the third minus 2x to the fourth plus 10x minus 4x to the fourth minus 3x to the third. No, make that a plus 3x to the third. And then minus 9x. We'll go with that. Okay, so you've got one polynomial that's not in parentheses because there's no need. All those terms are different. And then another polynomial that is. And we're going to take that and distribute the negative to all these terms. And then we'll combine like terms however we can. So let's write out the list. 3x to the third minus 2x to the fourth plus 10x minus 4x to the fourth minus 3x to the third plus 9x. So you notice how all of those final three terms got their signs changed. Okay, and then remember, you can only add like terms if they have the same power. So I'm going to highlight stuff that can be added. Negative 4x to the fourth can be added, and negative 2x to the fourth can be added. So put those two together, and we have negative 6x to the fourth. And that's going to be our biggest term. We want to start with that one because that's the highest power if we're going to do it in standard form. Next one, we would combine these two, the 3x to the third and the negative 3x to the third. So that's a unique case where those are just going to go away, right? 3 minus 3 is 0, so that term is no more. And then the last term would be the 10x and the 9x, and those would combine to be plus 19x. So that would be your final answer. Let's actually go continue this discussion about what are the features of this. So a few people can share their thoughts. Ryan, what's the degree on this? It's just the highest exponent we see. So it's 4 on that thing, right? Negative 6x to the fourth, okay? What's the leading coefficient? Kate H. Negative 6, good. Let's talk about end behavior then, okay? If that's the situation, what does the graph look like overall? Okay, let's make a little sketch, even though we know it's not perfectly accurate. Kate M, what do you think? Is it up, down, line, or line?
It would be up.
Look at the negative leading coefficient,
it would
though.
Be down.
Down with a
Like,
parabola, because it's an even degree, right? So it's going to look something like that on the ends. Okay, now let's actually do the end behavior. Ready? So as x goes to negative infinity, y goes to something. We'll fill it in a minute. And as x goes to infinity, y goes to something. Ellie's online. Rowan's online. Allie, what's the first one? As x goes to negative infinity, y goes to? Negative infinity. Lovely. And then as x goes to infinity, Allie, y goes to? You got it again. Nicely done. Perfect. Questions there? Cool. All right, what's next? Multiply polynomials. Okay, that's like an extended FOIL, right? So let's just do one quick example. 2x plus 3 times x to the third minus 2x squared minus 4x. Let's do that. If you like the box, use it. If you don't need it, no need. But what you're basically doing is you're distributing the 2x to all of those terms, and then you're distributing the 3 to all of those terms. Okay, so let's write it out. We've got 2x to the fourth. You guys cool with that? 2x times x to the third. Then we're going to add the exponents. And then we're going to have minus 4x to the third. That's the 2x times the negative 2x squared. And the last distribution is going to be negative 8x squared. Okay, now we do the 3 to everything. So it's going to be plus 3x to the third minus 6x squared minus 12x. And now we combine like terms. So there's nothing to combine with the first one, so that's done. There is a negative x to the third that comes out of these two. A negative 14x squared out of the other two, and then a minus 12x. Did I get that right? Yeah, that's all right. Good. Okay. All right, let's keep the discussion going on end behavior. Okay, Abby, what's the degree?
4.
Good job. Somebody else, what is the leading coefficient? Gia?
2.
2, and 2 is positive. So what does this mean, Chloe? How is the graph going to look overall?
Like upward facing for
Beautiful. So that means that's overall what it's going to look like. Let's do end behavior. As x goes to negative infinity, y goes to something. And as x goes to infinity, y goes to something. Okay, let's talk to Ariana. What do you say for the first one? As x goes to negative infinity, y goes to... Beautiful. And the second one? Nicely done. Cool. Questions there? Okay. You need to be factoring experts on this test, on this final, okay? Like the easy stuff like this, x squared plus x minus 12. There's one that I consider very, very easy. And then I'll also talk about some of the harder cases too, okay? Tell me, what is this one? 3 and 4. Which one gets the negative? The 3 gets the negative, right? Because that inner product we want to be positive x, okay? So easy ones like that, as well as hard ones where it's something like this. X to the third plus 6x squared plus 8x. Here, let's talk to people individually. Laura, what's the GCF here?
Oh gosh. X squared.
Just x,
Oh,
right? They all share at least an x. So then we can boil it down to this. Okay, now what, Drea?
you have to factor
Do it for me. What multiplies to 8 and adds to 6? Beautiful. Plus 4 and plus 2. Nice. So we took something that was a third degree and we factored it really nicely. And now we got know our 3 zeros. Braden, what are our 3 zeros?
-4, -2, is it 1?
0. Right? When x is a factor, 0 is a 0. So that's thinking of setting each of those things equal to 0. Very nice. Any questions there? Yeah.
Wait, what happened if x wasn't the greatest common factor? What would this
Then you would be impossible to factor.
Oh.
Yeah, you wouldn't be able to factor it unless you could take something out like that.
No, if you could take and then you could take 2x out.
Oh, okay, that would then 0 would still be a 0. Because think about what would happen. We would set 2x equal to 0. Well, what's the solution to that? Still just x equals 0. Okay, so yeah, if there was a 2x in front or an 8x in front, same deal. Ali?
Could you do one with a number at the very beginning?
Yes. Let me make a good one for you. Okay, can you try factoring this one, please? Try taking 4x squared plus 5x minus 6. Factor it. Show it. Wait. Show it. All right, here it is. This is what I say. You have to mess around with it a little bit to get it. But it's 4x minus 3 and x plus 2.
Is there another
No. Here, tell me what you think it is. And I'll show you how you can check yourself.
2x minus 2 and then 2x.
Okay, watch. The inner terms are negative 4x. The outer terms are 6x. Those don't add to 5x, right? You can always check your factoring by just doing that multiplication. Okay, there's another kind I want to show you guys that I want you to be comfortable with. Remember this kind where we had x to the third plus 4x squared minus 3x minus 12? Where we would do it by, remember how we would group it? Like take the first two and take the second two and work on each of those independently and then see what comes out of the whole thing. So here's what I mean. Take out an x squared from the first two. And then what can I take out from the second two? Negative 3, great. Leaving us with x plus 4. Remember, we want to set it up. We want it to work so that these two pieces match. And now that they do, I can factor that out and show you what happens. Okay? So this turns into x plus 4 as one factor, and then x squared minus 3 as the other. This is actually a really good one because it helps us understand that there's something complicated we have to do with that x squared minus 3. Okay? We know that one of the zeros is negative 4. But the other two zeros, can you tell me what they're going to be? Nope. Nope. Look, x squared equals 3. And if I root both sides, what are the answers? It's going to be root 3 and negative root 3, right? So root 3 and negative root 3. So remember, finding zeros is sometimes involves a little more work than just looking at it, right? This is when you've got an x squared minus 3. This is a fundamentally different idea than what we have going on here. This is linear, this is quadratic. So that's how we're going to get those zeros. Questions? Okay. And
On the final?
yes. And behavior. Okay, 4 cases. Ready? There's this one. There's that one. There's this. And there's this. Okay. This is odd degree. Odd degree. This is even degree and even degree. Did she fall asleep? No, she's there. Is that your paper?
Oh,
This is positive leading coefficient and negative leading coefficient. And then positive leading coefficient and negative leading coefficient. I was just doing the final this morning, creating the key for my colleagues, so I have it fresh in my mind. There is at least one multiple choice question that's just like this. Okay, so as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to positive infinity. That's that case. Okay, next case, as x goes to negative infinity, y goes to infinity. And as x goes to infinity, y goes to negative infinity. Remember what those mean, by the way. It just means left and right and up and down. Whenever we're talking about x's, we're talking about left and right. So this means left, up. This means right, down. You can kind of bring them back to ordinary language like that. All right. Next, this one, as x goes to negative infinity, y goes to positive. And as x goes to positive, y goes to positive. And then finally, as x goes to negative, y goes to negative. And as x goes to positive, y goes to negative. Those are the 4 cases that we studied for n behavior. Good? Did you say you're cold?
Yes.
I'm sorry. Are you sick?
No.
You want to go for a walk, warm up?
What?
I'm like hot. I got a fan on myself over here. Is that weird? Yeah,
I am
maybe.
wearing slippers. My toes.
Oh, your feet look so warm in those socks. It's good. I don't know. I guess your activity right now is a little more passive than mine. I'm up here like talking about math and getting excited. You guys aren't as excited about that. Okay, long and synthetic division. Let me give you this is best done with an example. I want to say now, this is a really big hint if I'm able to actually tell you this. Let me confirm that it's true before I tell you. So let me set you up with a problem, and then I want to go do a little searching, and then I'll come back to you, okay? So let me set you up with a good one here. Okay, here we go. Can you guys take this polynomial, x to the third minus 2x squared minus 33x minus 36, and I want to give you a hint. The hint is that x plus 4 is a factor. So you know what that means. You're going to be using some synthetic here to undo that fact. And so the directions are this. Find all zeros. Okay, you guys go to work on that. I'm going to do a little research and get back to you with a nice little thing about the final. Okay, friends, the recording is back. The info that I wanted to share with you is this. You never on the final have to do long division. You will always be able to do synthetic division. Okay? Good? That's the hint. All right? So don't bother practicing very much long division. It's always going to be doable with synthetic. Okay? All right, so let's look at the problem I just asked you to do. The first step we should all be taking is a -4 in the corner and doing our synthetic. This leads us to x squared minus 6x minus 9, which can't factor. There's no way to multiply to -9 and add to -6. If you try the options, it's just not going to work. -3 and 3 doesn't work, right? 9 and -1 doesn't work. Nothing works. So you're forced into quadratic. So quadratic turns into opposite b, you know the process, b squared minus 4ac. Now the trouble is, this is a little odd because it turns into 36 minus -36, which is 72. Okay, so here's where we are. This is our unsimplified version. Now root 72, I grant you, that's a hard one. So let's talk about how root 72 works. Root 72 could be thought of as root 9 and root 8, but that's not big enough. You would have to do more to that. So instead, think of it as root 36 and root 2. Okay? Root 36 becomes 6. That's very convenient because we already have that 6 in there so we can simplify stuff. So this turns into 6. That doesn't change. 6 root 2, that's what root 72 becomes, and then all over 2. Then if we do this division, it's 3, and if we do this division, it's 3. Those are our 2 zeros then, right? -4 as a 0, and I don't care if you split them up or not. You don't have to. 3 plus 3 root 2 and 3 minus 3 root 2.
Wait, I thought you said when there's like the 2 on the bottom, you don't divide the.
You split it up into 2 fractions, which means that they both simplify, right? You go 6 over 2, and then 6 root 2 over 2. Does that make sense?
So you can simplify it. It's not.
You can simplify, but what you can't do is just cross off those. That's cheating because you're violating the fact that this thing is a unit. So in order to actually simplify, we need to say, well, it's made up of this piece and this piece, which are both over 2, and then it can simplify further. Okay? Welcome, Daniel. I'm sorry you didn't have the link. We're just going through kind of a chapter 3 review right now. The video will be posted if you want to watch it later. Okay. Questions there? What would have made this problem easier is if that thing had been factorable, right? And that does happen sometimes, in which case you don't have to do quadratic. You can just get the zeros through factoring. Okay, last topic, and this is the one you guys asked about, factored form to graph understanding multiplicities, okay? So let me delete this little side work I did, and we'll get into, slow down? Yep, right there. And Daniel, if you have the review packet to show me, that was homework. Just go ahead and send it to me in an email if you have. It was just the first 2 pages you had to do. I forget where to look. I have to look here if I want to talk to the online people. Right? Is that right? Let me see my picture. Hello, friends. How are you? Am I looking directly at you? Kind of creepy, right? None of them have their cameras on, just like the old days. Remember last year? No one would turn their cameras on. No one would ever talk. So sad. I hate it. Please don't go back to that. I don't want to go back to that. I don't want to sit in my basement and teach. It's so depressing. It doesn't. I don't care what you like, girl. We are coming to school. I don't care that you like sleeping in. I want school. All right. Multiplicities. Let's go. I'm going to give you 2 examples, okay? One of them we'll make nice and simple. X plus 2 squared, and x minus 3. There's nothing crazy here because there is a nice positive leading coefficient. That's what's nice, okay? So let's go through all the details and we'll try and sketch a graph. The degree is, ready for this? It's 1 plus 2 plus 1. So what's the degree? 4. Good. Okay. That means that on the ends, this graph is going to be going up, right? So as far as end behavior, it's going to do something like that. Now, it's going to do interesting stuff in the middle, but at the end, it's going to be up, up, okay? All right, what are the zeros? Tell me. 0. -2. Wonderful. What are their multiplicities? 1, 2, and 1. Excellent. Okay. Now let's talk about the behavior. That means at 0, it's going to act like a line. At -2, it's going to act like a parabola. And at 3, it's going to act like a line. Therefore, we can make a sketch. Here is 0, here is -2, and here is 3. Now remember, it's got to start high. It starts high. So it's going to come in and bounce. Then it's going to go through at 0 and then through again at 3. And I know that I did that fast, but what we're doing is we're just modeling it off of the behavior that we wrote up here. It's going to bounce at -2. It's going to go through at 0, and it's going to go through at 3.
I thought 3 was a square.
Nope.
Oh, no.
Only if the multiplicity is 3, right? Yeah.
You know if it's even or odd by the degree that you added?
Yes, we know that it's even or odd by when we add the multiplicities, what do we get? Because if we were to expand it, if we were to do all the crap to get it in standard form, it would be a 4th degree polynomial. Yeah. Good. Okay, let's do another one. This will be a little harder and you're going to do it by yourself. Okay, so let's say that the function is f of x equals -2. There, it's a negative leading coefficient, guys, okay? X plus 4 to the third, x minus 1 squared, and x minus 5. Go. Show all the work. See what your sketch looks like. No, that's just a constant. That's just the leading coefficient.
So that one doesn't count.
It does not count, right? -2 is, well, -2 is not a 0, so that makes perfect sense, right? -2 just affects whether the graph is stretched or how it works like that. It's these things that create the degree. It is down, you're right. It opens down. There is going to be a squiggle somewhere. There's a squiggle at 3, at -4, I mean. So here is all my... -2 is the leading coefficient, yeah. So here's my work. I wrote the degree is 6, and I noticed a negative leading coefficient, which means on the ends it's going to open down. I listed my zeros, -4, 1, and 5, and I listed my multiplicities that went with them. So we know we have a squiggle at -4, a parabola at 1, and a line at 5. What's up, Drea?
Why did we use the x on the first one, but not the -2?
Great question. X actually produces a 0, right? A 0 of 0. But -2 does not produce a 0. It's just a leading coefficient. That's why we did not account for it. Okay, so it starts low, it squiggles, it bounces, and then it goes through. That's the shape of the graph. And remember, in class, we always teach you a little bit beyond what we're going to put on the final. There's nothing with this much complexity on the final, but there's one where you have to bounce and go through. You know, at least there'll be a case of bouncing and going through once. I don't think we put any of the squiggle cases on there. I don't think all teachers teach that, so. Yeah. All right, I'm done with the review lecture. The rest of the time is devoted to Math Excel, review packet, or anything else you can find on the assignment sheet that's like good review, you know? There's tons of little things on there that you can use to study. And of course, yeah, have a break for 5 minutes. No cafeteria today. I'm not supposed to do that, so I really don't want to get that to be a habit. Okay? All right. I'm going to stop the recording. Let's see.